Ladies and gentlemen, it's an immense privilege and pleasure for me to be here at the David Game College in front of so many eminent individuals. In particular, I'm very grateful to John Dalton, who has spent much time with me behind the scenes setting up this medical program. We will be looking at the anatomy of the brain, or neuroanatomy, because the anatomy is crucial to understanding the actual processes that go on in the brain and allow it to carry out the executive functions. In particular, we'll be looking at the cerebrum, the cerebral cortex, the brainstem, the cerebellum, the subcortical structures, and I'll be mentioning the cranial nerves. We know that the brain is the central organ of the nervous system. It's one of the most protected organs in the human body. The skull is dedicated to its protection. It's one of the most complicated organs in the body and probably one of the least understood. Each neuron does not just make one single connection with another neuron, but there are complex neuronal networks, and this interaction happens via junctions called synapses. And synapses are to the tunes of not billions but trillions. The largest area is called the cerebral cortex. This region at the back in pink is called the cerebellum. Underneath this cerebral cortex are subcortical, sub meaning below, cortical referring to the cortex structures, such as the hypothalamus, the pituitary gland, the thalamus, the amygdala. All these things we'll look at during the course of the lecture. This cross-section here of the brain shows that the brain does not have a smooth surface. In fact, there are invaginations and grooves. So the frontal cortex is shown in yellow. The frontal cortex determines personality, memory and problem solving, sexual behavior, and motor innovation. So the frontal lobe has a major role in a person's personality and in memory. Now put the two things together. So this is, remember we said the toes are innervated at the center, the lips are innervated in the middle from the lateral aspect, and the hands and arm are affected from about this region. Now can you see that the region supplying the legs is different to the region supplying the hands from an arterial point of view? That's why when patients have stroke, some of them end up with hand and arm defects, and some of them end up with leg defects, because a different vessel has been affected. The parietal cortex is involved in integrating sensory information. So if somebody taps you on the back, that's a sensation, and that sensory information is relayed to your post-central gyrus, which is this gyrus here after the central sulcus, and that will tell you exactly where somebody touched you. Remember, one of the purposes of these lectures is so that you can, if you're applying to do medicine, and I know there's a lot of people in this audience who are applying to medical school, is for you to use this knowledge, okay, when you're at the interview stage. And the way to really exercise it, because the interviewer is not going to necessarily say, what's the threshold voltage for a neuron to fire? You know, he's not going to do that. That just doesn't happen. They're not there to catch you out. But what he will say is, can you tell me about an interesting patient you saw? And that's how you choose what topic, broad topic you want to talk about. And then you bring in all the other information through your own skill. And I encourage you after this lecture to go and see a neurology case in hospital if you're able to. If you're able to get work experience, please go onto the neurology wards. Fascinating conditions. If not, you may know someone who's got a neurological condition. You might know someone with dementia, with Alzheimer's disease, with motor neuron disease, with Parkinson's disease, with multiple sclerosis. You might know someone whose pupil is a little bit down and out. That's a neurological condition. So you can say, I shadowed a consultant neurologist, and during the placement, I saw a patient who had their arm fixed tightly in this position and was unable to move their arm. a stroke gives you this type of picture. And a stroke can be hemorrhagic, it means there can be a bleed on the brain, or it can be ischemic, which means that there's not enough blood supply to the brain. What I'd like you to do for me is just put your arms out like this. Okay. This position is essentially with all of his muscles extended. Okay? This is an extended position. His legs are extended. His arms, his wrist, his fingers are extended. Now what I'm going to do is I'm going to put him in a flexed position. The first thing I'm going to do, if I may, sir, just with your hands, is flex your fingers. Can you see just his fingers on this side are now flexed? His thumb is now flexed. His wrist is now flexed. His elbow is now flexed. Can you see what I'm doing? And his shoulder is now flexed as well. Okay? Now this is the position you get in a stroke. The reason is a stroke affects the extensor muscles more than the flexor muscles. So relatively speaking, the flexors are still working, but the extensors are not. Does that make sense? And that's why you see stroke patients in this position. They don't end up like that. If they ended up like that, it would mean that their extensors are working, but their flexors are not working. What we've been able to do in this lecture is take a journey through the brain. We had a look at the neuroanatomy, in particular the cerebral cortex, the subcortical structures. We also looked at the brainstem, and then we looked at the neuron and the action potential, and we looked at a clinical case. Thank you very much.